Hello and welcome back. So in the last episode, we were discussing about system modeling and we have discussed on a basic diagram, that is activity diagrams. So in this episode, I'm going to discuss on use case diagrams. Okay, so let's see what is use case diagrams. So use case diagrams are used to gather the requirements of a system, including internal and external influences. So these requirements are mostly design requirements. So when a system is analyzed to gather its functionalities, use cases are prepared and actors are identified. When the initial task is complete, use case diagrams are modeled to present the outside view. In short, the purpose of a use case diagram can be said to be as follows. Used to gather the requirements of a system, used to get an outside view of a system, identify the external and internal factors influencing the system, and show the interaction among the requirements as actors. So, how to draw a use case diagram? So, use case diagrams are considered for high-level requirement analysis of a system. So when we are planning to draw a use case diagram, we should have the following items identified beforehand. So first item to be identified is functionalities to be represented as use cases. Then actors involved. Then relationship among the use cases and actors. So how to draw a use case diagram? So after identifying the above items, we have to use the following guidelines to draw an efficient use case diagram. So the name of a use case is very important. So the name should be chosen in such a way so that it can identify the functionalities performed. Okay, so when the requirements of a system are analyzed, the functionalities are captured in use cases. And the second thing, which is give a suitable name for actors. So the second thing which is relevant to use cases are the actors. Actors can be defined as something that interacts with the system. So actors can be a human user, some internal applications, or maybe some external applications. Then show relationships and dependencies clearly in the diagram. Then do not try to include all types of relationship, as the main purpose of the diagram is to identify only the requirements. So we should not complicate the diagram using all types of relationships. Then use notes whenever required to clarify some important points. Now I'll see a figure. This is a figure showing the use case diagram of a medical receptionist, and we have register patient, unregister patient, view patient info, transfer data, and contact patients. Okay. Now this is the actor, that is the medical receptionist. So from the figure, it is evident that use case diagrams specify events of the system and their flows. Okay. So this diagram here, it is used to describe some type of interactions among the different elements in the model. So the interactive behavior is represented in UML by two diagrams known as a sequence diagram and a collaboration diagram. So let's see both the interaction diagrams. So the purpose of interaction diagrams is to visualize the interactive behavior of the system. So visualizing the interaction is a difficult task. So the solution is to use different types of models to capture the different aspects of interaction. So here we have sequence and collaboration diagrams are used to capture the dynamic nature, but from a different angle. First, let's see what is sequence and collaboration diagrams, right? So sequence diagram emphasis on time sequence of messages, and collaboration diagram emphasizes on the structural organization of the objects that send and receive messages. So one is involved on the time sequence, and other is involved on the behavioral aspects or the structural organization of the objects. Now, the purpose of interaction diagram is to capture the dynamic behavior of a system, to describe the message flow in the system, to describe the structural organization of the objects, to describe the interaction among objects. Following things are to be identified clearly before drawing the interaction diagram. Let's see what it is. Objects taking part in the interaction, message flows among the objects, and the sequence in which the messages are flowing. Then object organization. Okay, first we are moving on to sequence diagram. So sequence diagrams in the UML are primarily used to model the interactions between the actors and the objects in a system and the interactions between the objects themselves. Sometimes the interactions will be between the actors and the objects, or maybe between the objects itself. Okay, a sequence diagram shows the sequence of interactions that takes place during a particular use case or use case instance. So here is a figure which shows the diagram of a sequence diagram. So here the objects and the actors involved, these are the objects involved and this is the actor involved. All these objects and actors involved are listed along the top of the diagram, okay, with a dotted line drawn vertically from these objects. See, from the objects there is a vertical line, dotted line drawn from the objects, okay. Here annotated arrows, see we have annotated arrows here, right? So annotated arrows indicate interactions between objects. So objects interact using these annotated arrows. The rectangle on the dotted lines indicate the lifeline of the objects. See here is a rectangle, right? So this is the lifeline of the object patient info and this is the lifeline of the object MHCPMS database. MHCPMS means that is the name of a hospital, the database related to the hospital. Now, authorization has a lifeline, a very small lifeline. So, these all indicate the lifeline of the object's concern. Lifeline means the time that object instance is involved in the computation. Now, the sequence of interactions are read from top to bottom. Okay. The annotations on the arrows, see you have view info, patient ID, then report info, patient ID, user ID, everything is given, right? So these annotations on the arrows indicate the calls to the objects. So whenever view info, patient ID is called from the medical receptionist, the patient info object is being called, okay? So these annotations on the arrows indicates the calls to the objects, their parameters and the return values. Now, a box named alt is used here, okay, with the conditions indicated in square brackets, okay. Alt means alternative messages. So, alternative messages are indicated in square brackets with alternative interaction operation separated by a dotted line. See, alternations are separated by a dotted line here, okay. Now, we can see how the figure is read, okay. The medical receptionist triggers the view info method in an instant P of the patient info object class, supplying the patient's identifier PID to identify the required information. So, P is a user interface object which is displayed as a form showing patient information, okay. Now, the instance P calls the database to return the information required, supplying the receptionist identifier to allow security checking. So at this stage, it is not important where the receptionist UID comes from. Okay. So the database checks with an authorization system that the receptionist is authorized for this action. So now if authorized, the patient information is returned and is displayed on a form on the user screen. Now suppose if authorization fails, then an error message is returned. The box denoted by Alt in the top left corner is a choice box indicating that one of the contained interactions will be executed. The conditions that select the choice is shown in square brackets. Okay. So this is how a sequence diagram works like. Okay. Now we have collaboration diagram, which is the second interaction diagram. Okay, let's see what is collaboration diagram. Okay, they are very useful for visualizing the relationship between objects collaborating to perform a particular task. It shows the object organization. I first of all said that a sequence diagram shows the time sequence and collaboration diagram shows the structural behavior or the object organization. Then there are three primary elements of a collaboration diagram. The first element is the objects, links, and messages. Let's see what are all these elements. Now, objects, we all know first of all that objects is something that are participating entity in the collaboration diagram. Now, let's see what is links are. Okay. Now, links, the connecting lines drawn between objects in a collaboration diagram are known as links. Okay, they enable us to see the relationship between objects. So each link represents a relationship between objects and symbolizes the ability of objects to send messages to each other. Okay, a single link can support one or more messages sent between objects. So here only a single link is used, but a single link can represent one or more messages. Okay. So if an object sends messages to itself, the link carrying these messages is represented as a loop. Okay, now let's see what is messages. Okay, messages in collaboration diagrams are shown as arrows. Messages are composed of message text prefixed by a sequence number. So the sequence number indicates the time ordering of the message. So the first message in a collaboration diagram is always numbered 1, the second is 2 and so on. So we are numbering the messages which we are sending. Let's see how a collaboration diagram looks like. So first of all, we'll design some steps which will lead to draw a collaboration diagram. Let's see, determine the scope of the diagram is the first step we have to take. Now, place the objects that participate in the collaboration on the diagram. Then, if a particular object has a property or maintains a state that is important to the collaboration, set the initial value of the property or state. So, if any object has a property or a state, first we will set the initial value of the state. Then create links between objects. Okay, these are the steps which we have to follow for drawing a collaboration diagram. Now create messages associated with each link and add sequence numbers to each message corresponding to the time ordering of messages in the collaboration. Now this is a sequence diagram. See here there are objects which are listed on the top and we have a lifeline or time sequence of each objects. Then there are arrows indicating messages. Okay. Now I am showing the same sequence diagram in the form of a collaboration diagram. See. Here in this figure, see the objects are being categorized in a special format and we can see sequence numbers are given to messages. Send order is the first message that is being numbered 1. Confirm is the second message that is being numbered as 2 and dispatch is the third message which is being numbered as 3. Okay. So if time sequence is important, then sequence diagram is used. If organization is required, the collaboration diagram is used. So see we have a structure here. See first initialization, then customer order, special order, end of process. So if we need a structural organization, we have to choose for collaboration diagram. Thank you so much.